I hope everybody can hear me and see me, okay? And otherwise, please let me know. Before I start, just want to make sure that people understand that at the end of the lecture, you're welcome to ask questions, okay? And I'm going to try to answer them live, okay? Real time. If I can't answer them, please take a rain check. I'll try to answer them maybe in the comments section or next week or whatever. And talking about rain check, there's a fellow out there. He asked a question. I was going to answer it today. The question requires a full lecture, okay? And that's what I was going to do today. But I had to change because something else came up which I think had a little more urgency. And so I'm going to have to postpone you. And really, I'm sorry about that. But as you will see, the subject matter of today is a little more important, I guess, right? What else? Let's get started. We have people who come here with an air of superiority. And they leave comments. Mainly they attack. They're not really listening in every case. Hardly ever, actually. They come here to teach, And we set them straight. So in order to understand what we do here, it's important to understand what the rules are of the University of bgaede, the School of bgaede, okay, the School of Physics of bgaede. And so here's one of the things that we always want people to understand. I don't always go through all this stuff. Maybe I should go through it more often, but here it is, okay? Our motto, School of Physics, we teach with a baseball bat. You come here with your arrogance, you know it all, and you begin criticizing without listening, without even understanding what the site is about. Hey, we're going to set you straight. Believe me, we have ways of doing that, okay? And you might say, isn't that a little violent? Well, we learned this from, if you watch Faulty Towers, John Cleese, maybe you remember this scene where Mr. Faulty goes in there and he threatens his car. And because the car won't start, well, then he goes in there and smashes it with with a branch that he found out there, okay? And that's more or less the way we like that style of teaching cars and people and whatever, okay? So we've subscribed to that form of teaching. And people say, Bill, you've insulted me, you've disrespected me, and blah, blah, blah. We don't insult or disrespect anyone. Here at the bgaede School of Physics, we treat everybody with the respect that they deserve, okay? And so if you believe that you don't deserve to be treated like that, well, you better justify it, A lot of people come with a little bit of underhanded tactics. They try to act candid, like, oh, you don't know enough, Bill, but let me teach you something. And, they don't even know what the site is about or what the questions that we addressed in the video were about. So they haven't listened to the video, but they maybe just looked at the title and they're already answering. They already know everything. And so we set them straight, and teach them with the respect that they deserve. And a lot of these people say, Bill, I don't like the way you treated me, blah, blah, blah. All I can say is those are the rules of the bgaede School of Physics. Your only option is to go to another school. Go watch Sean Carroll or deGrasse Tyson or, Sabine Hassenfelder or any of those. Just go over there. Maybe you're going to learn a lot more. And we'll be glad to refund your tuition. Okay, so no problem. Just go to where you think they can treat you better if you think you're going to learn something over there, right? Here we pride ourselves in saying that we are the only site on the planet, not on the internet, on the planet, that has something different to offer. And a lot of people say, oh, you're just bragging, Bill. You're boasting about nothing. No, believe me. You may not agree with what we teach here, right, with the lectures, but for sure we got something totally different than anybody else out there. So if you stick around, you'll find out. But if you just come in here and see the title of a video and begin answering, well, you're going to get a surprise. And another issue, here we have these people who, we call them idiots. And people say, oh, you called me an idiot. Well, we need to define that term. What do we mean by idiot? And it's I-D-E-O-T. Okay, we usually make the E a little bigger, okay, so that people are aware. It's not a misspelling, that is the word, okay. It's an individual with big ideas. Comes from the old Klingon language, regular people, rational people, they just have ideas. And these people have ideas, big ideas, right? And so we call them idiots and idiots for short, okay? So yeah, if you come here and you say something that is inappropriate or maybe not smart enough, yeah, we will address that using that term, okay? So these are the words you should, or some of the rules and words that you should become familiarized with, okay? We run a different site over here. And people say, Bill, you don't have too many hits and so on. Yeah, we're not here for the hits, okay? We have a little school in the middle of the prairie. It's a blackboard type of thing. I don't have any, any cameramen, any lighting, any, none of the fancy stuff of Hollywood. It's just me and God here. That's it. Us two. We're the only ones here, okay? So I do what I can. I just put a camera and try to teach like you would teach in any school, in the old-fashioned way. Okay? And yeah, people who get out of line, we put them back in line. Okay. Anyways, for many years, when I was in college, I was a follower of Richard Feynman and Carl Sagan. They were atheists, and so was I at the time. And I followed them because of that, because of all the things they said. They were great teachers in the sense that they delivered their thoughts very well to whoever listened, right? And these people are worth quite a bit. They're worth their weight in gold because they recruit a lot of people. And I stopped, following them, stopped being an atheist, among other things, stopped with the quantum and the relativity and all that nonsense. And I just abandoned all of that because what they were teaching was nonsense, was poppycock. That's what it was. And so here you have these two individuals, so you know who I'm talking about, okay? Richard Feynman and Carl Sagan, they were both atheists. And they did not only talk about atheism, in favor of atheism, they also talked about quantum mechanics primarily because they were, in general, interested in quantum mechanics. And they talked also about relativity. That was part of mathematical physics, what is known as mathematical physics. Okay. And yeah, I was a follower of them, but what happened? These people, these two individuals, what they taught was nonsense. And yeah, you can, here are other great teachers. They teach nonsense. I think you'll recognize some of them if you've been around religion, Oral Roberts, Jimmy Swaggart, Billy Graham, so on. These people are very popular in another field, and they're excellent at what they do. In other words, talking, delivering a message that they want to deliver. And again, these people are worth their weight in gold because they recruit a lot of people. They really recruit a lot of people. So, they're worth a lot of money. And they have jets and so on, and so forth. So for me, it's important, not, the delivery is great. I love to listen to Carl Sagan, to Richard Feynman. But when you look at, what did I learn from them? And what I learned from them was garbage. Okay? It was poppycock. And among the things that I learned from them was the wrong arguments for atheism. Why atheism has nothing to do with anything. It's just another religion. And people say, well, what are you saying? Did you become a Christian? No. In fact, I use the same argument against all three, against atheism, theism, and agnosticism. All three belong in religion. And here let's define atheism, and it'll give you an idea why I rejected not only atheism, but I didn't, go into theism and agnosticism either. All three of them are religion. Here it is. Here's the definition of atheism. One of the three religions, together with theism and agnosticism, that follow what? The mathematical method. We call it the mathemagical method. It's called mathemagics. That's what they do. They do everything with magic. And they have that way of doing science, which has nothing to do with science at all. Okay, and we've inherited that from the 17th century. That primarily the fact that you got to do an experiment and that you collect evidence, turn it into math. You do a measurement, you bring those measurements in, and from there you develop maybe an equation, and now you convince your colleagues, and eventually, you convince everybody that you are correct, that they should believe in your theory. And none of that has anything at all to do with science. Science we don't believe. Science we explain. And that's where we have a difference with a mathematical method, which is what all these three religions, all including in their mathematical physics as well. They all follow this methodology, right? And they all have a wrong idea of what science is to begin with. Okay, and so here you have it. These religions, as I call them, atheism, theism, Gnosticism, mathematical physics, right? They all rely on belief, on knowledge, on skepticism. They all talk, do you believe in the existence of God? Do you believe in the existence of space-time? That's what it is. It's all about belief. And the guy said, well, I don't believe in space-time. And the other fellow says, then you're a crank. Get out of here. You're a crank. Okay, so I like to say belief is personal. Every person has to believe for himself, just like every person has to love for himself. I mean, I can't love for you. I can't love your wife or your girlfriend for you. Okay, you have to do that. Okay, and so belief is personal. On the other hand, explanation, which is what science is about, that's universal. Everybody can relate to an explanation, right? And we should all understand it in the same way. But should if there's a problem in understanding it in the same way, then you bring them over and you say, look, this is what you missed. Explanations are objective, so it's whatever mechanism and so on, the causes. If you're going to put something on the board and explain the cause of why something happened the way it did, right? And then again, in that sense, it's universal. We should all understand the same thing because it's about understanding. It's about tuning in to what the presenter presented. Now, belief, on the other hand, one guy believes one thing, another person believes another. So yeah, belief is personal and explanations are universal. That's the bottom line. Okay, so what's wrong with this so-called scientific method, this science thingy, this methodology that the mathematicians developed in the 17th century? And let's go over that a little bit. Here it is. Hey, here we have the Science Council. It says, what is science? Science is the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on what? On evidence. So they think science has something to do with evidence. It's about knowledge, etc., etc. And there you see the scientific method, the main points that they want people to learn, I guess, catechism that people must memorize. You have to have an observation. Okay, it's got to be objective, whatever objective is, but you need an observation, right? Then you collect evidence of some kind. You do an experiment. Induction means you're gonna, come up with some kind of theory, tentative theory. They call it a hypothesis, and that morphs into a theory. And when more than 50% vote for the theory, now it becomes a fact. It becomes the reigning theory, so to speak. You got to repeat the experiment. If it's not a repeatable, in other words, if someone else cannot reproduce your results, then you have a problem. Someone has to do a critical analysis, right? They criticize your theory. In other words, you got to put it kind of to the test for the colleagues to look at it and analyze it. It's called peer reviewing. And then you have verification and testing, meaning, after a while, someone will try to either debunk it or verify, confirm it, one of the two. So what's wrong with this way of doing science? Well, let's begin with a definition of science itself there. Science is not a pursuit. We do not pursue anybody in science. Okay, so this notion that science is an ongoing process is totally irrational. That's not what science is about. Science is not an ongoing process. In science, we have to explain. Once you explain, you're done. Another person can go in there and explain something else, and a different explanation, a different theory, and that's it. But this notion that forever we look for explanations or for causes or for whatever descriptions, and we never answer the question, that's irrational. No, science hopefully stops at some point. At some point we stop science because now we know, as they say, we understand the explanations. So no, it's not a process. And then the other question here is application. No, science has no application whatsoever. That's technology. In science, we do not apply it to anything. You say, well, what's the purpose of science? Well, the purpose of science is like when you go and see a show, maybe a comic, someone making you laugh. Well, what was the purpose of that? What was the use of that? Is there any application for that? No, it was just for your amusement. That's all it was for, and that's what science is. Science is only for your understanding of how the universe works. That's it. There's no more than that in science. So, confusing it with technology, with the development of gadgets by trial and error, one thing has nothing to do with the other. Okay? So, no, technology and science are not synonyms. One has really nothing to do with the other. You have to keep in mind, people like, Thomas Edison. He knew nothing about science. In fact, he knew very little about inventing and about technology as well. What he knew a lot about is business. He was a businessman. And what he did, he organized his people at his shop over there in New Jersey, and what they did was develop things, primarily the filament, and they developed it by trial and error, by trying different things, different materials. Did Thomas Edison know anything at all about electricity or atoms? No, remember, atoms had not been invented yet. The atom, Dalton's maybe atom, but not the atom that these people are going to develop in the 20th century. So we're talking about, a filament that they just developed by trial and error, trying different things. That's it. So you don't need to know any science to do technology. All you need to do is try something, say, hey, I like that effect. Maybe I can use it for something like, to make money. And that's it. It doesn't go beyond that. And that's not science. That's just technology. Okay, knowledge. We have a problem with knowledge. Knowledge is belief. Science is not about belief. And so when these people at the Science Council, they say, hey, science is about belief. No, I have a problem with that. Science has nothing to do with belief, and that's what knowledge is, justified true belief. We're going to cover that today. But, just give you an idea that these people are completely misdefined the word science. Every word they have in there has nothing at all to do with science. And the other important one there is evidence. They say that science is somehow about evidence, presenting evidence, but they think it's a courtroom where the lawyers come in there, the prosecutor comes in there and says, oh, I'm going to convince the jury to vote for my side of the case. That's why he presents evidence. But that's not what we do in science. In science, we're not in the process of, or in our goal is not to persuade, convince, convert, and recruit people. Our goal is to explain so that people understand an objective explanation, right? And then they leave and they can believe whatever they want. That's why I'm saying, the explanation, that's universal. We should all understand the same thing. The same case, you could say, in a courtroom, We should all understand the same thing from the prosecutor, at least, his side of the version. We need to understand that well. What they do later on inside the jury room, where they decide, hey, that's belief, that's voting, that's raising your hand. So one thing has really nothing to do with the other. Okay, so do not confuse evidence with science. Science is not about evidence because we do not try to persuade people. We don't twist their arms. We do not try to force them to believe like we do. We just explain, you understand, we're done with science. What continues now is religion. Okay, and then they have this thing called observation. Well, observation has two problems. One is gawking. You observe something, you don't understand anything. Does that make you a scientist because you observed? Okay, so you observe something, but you don't know what happened. You cannot explain it. And the other problem is testifying. You become a witness. You say, I observed. So they go to the, like the CERN, Large Hadron Collider, and they say, we observed particles. Or they say, the astronomers say, we observed a black hole. You did, huh? How did you observe a black hole? How did you observe particles? Did you see them with your eyes? Is that what you're saying? And that's where the problem is. The person is testifying, and they don't realize that what they're really having is not what is called an observation. What they're doing is making an assumption. They're making an assumption that there are particles, and they're making an assumption that there's a black hole. And they're turning those assumption into observation. They use the word observe, and that's a very dangerous word because people are thinking. What people are thinking when these people use those words, they say, oh, they observed it, like they saw it with their eyes, because that's what observe means to the common man. So they use this word observation. Is very dangerous. Should not use it at all in science. We do not observe, we do not gawk, and we do not testify by saying, I observed. We don't care what you observed. You have to make an assumption, and from that assumption, build your theory. Okay, there's another thing here, and that's we already covered evidence up there with persuasion and so on. Induction, they say that, you come up with a tentative theory, what they call a hypothesis, and it ain't, but we'll cover that also later. The issue is that, induction involves explanations. And the problem with that is that, there are no explanations in the religion of mathematical physics. Nobody does explanations in so-called science, at least as related to physics, in other words, mathematical physics. Here's a testimony from Richard Feynman, which I talked about earlier, and he says that they gave up on that, on explanations. Says, the more you see how strangely nature behaves, the harder it is to make a model that explains, right, how even the simplest phenomena actually work. So what theoretical physics has given up on that. He says they've given up on explanations, okay? And just in case we have a more modern fellow, more close to our days, and he says the following. He says his name is Donald Simonek, and he's a professor. I guess he's retired now, and he says science doesn't explain. Science describes. Why did he say that? Well, because he's a mathematical physicist, and mathematical physicists don't explain. People want explanations. They want to know how gravity works. They want to know, how electricity works, how a magnet attracts another one, etc. They want explanations, and he's telling you in your face, science doesn't explain. These two teachers here, Feynman and Simonek, they're both saying the same thing. They're saying, we do not explain. Don't ask us for explanation. What we do is describe. Why do they say that? Because math can only describe. An equation can only describe. An equation has no power to explain. And that's where the problem is. Okay? And so, when you ask them for an explanation, you're asking the wrong people because they're not in the explaining business. Okay? They're in the description, in the describing business. That's what they do. Why? Because that's all that math can do. And so, forget about explanations, but that's what they say. If you look at the definition, they always put the word explanation, but they never explain, at least not as far as mathematical physics is concerned, okay? And then here you have the last one, which is verification and testing. What they actually do, they're censoring. You know, if you don't bow down to Einstein from the start or to Niels Bohr, you're a crank, and they kick you out. They don't even listen to you. So that's what verification means. We don't want your stuff to reach the public. That's what they're telling you. Even though you may have the correct theory, it doesn't matter. It's just not going to reach the public. We're not going to allow it to reach the public. And so they have all this methodology, which we say has nothing to do with science. None of this has anything to do with science. But this is what the Science Council has. So just be aware that this is the notion they have of science. And what I'm going to be talking about today is people, you know, who think that what I just showed is science. And this is what they follow. This is what they think is a scientific method. This is what they think is science. They believe it on the basis of authority, because this is what maybe they learn in high school or college, or maybe this is what they read out there in the literature. They believe in it because it comes from not only authority, but it also comes from tradition. You know, we've been doing this for 400 years, so you're going to change that, Bill, now? Yeah, I'm going to change it completely. I'm going to wipe it off the board completely. None of it survives. And then they think that it's a question of raising your hand, you know, and voting. You know, all the mathematicians voted for this method, Bill. Are you going to challenge them? Who are you to challenge them? Okay, so this is the issue. And because of this, you have, I hope I'm still online. I got a yellow message there from Yahoo. Let me know otherwise, okay? Because I got a message that something might be wrong with the transmission. Okay, so let me know. Anyways, here we have a fellow, and his name is Reinhard Genzel, and he won the Nobel Prize in 2020, okay, for some nonsense related to black holes. And following this methodology that I just explained, okay, he comes up and he proves the existence of black holes, and for that he got his Nobel. Okay, here it is. His name, he's a German fellow, and he says the following. He says that he proved it beyond a reasonable doubt, and so he uses that criterion. Okay, and so he's saying, you know, he's using the criteria that we use in courts. He's saying you have to prove the guy guilty beyond a reasonable doubt, and that's what he's going to use. He's going to use that criterion, and he's going to present what? Unambiguous proof of the existence of what? Of black hole. He's going to prove the black hole, okay, the existence. And again, he talks about proof, and he says measurements of test particles. You know, it's not very easy to do. You know, particles that are close to a black hole, that's almost impossible, he says. But there's another way, and that's to look at what a very heavy mass, right, can do to space-time. So we have two concepts, mass, kilograms, right? Kilograms bending number lines. And so they say, oh, look at all those number lines. They were bent by mass. And he said, what else can it be if not a black hole? He can't think of any other process that could cause that kind of effect that he either simulates on his computer or that the astronomers saw out there. And so, you know, I have the mime version of what he says. You know, it's like you prove the existence of a chair. What else could the mime be sitting on? You know, so he's in that position. People say, well, he's got to be sitting on a chair because what else could it be? Otherwise, he would fall on his butt, right? And this is more or less how Genzel is treating this whole thing. He's saying, you know, there's got to be a black hole because the only way we can explain what's happening out there in the middle of space is with a lot of kilograms bending space-time. So he's already bought into the space-time number lines, field thingy, which are none of which are things. And he's going to give you a physical interpretation, remember that. So he's turning all these things, space-time, fields, energy, he's turning all that into physical objects. He's treating them for his physical interpretation, his explanation. He's turning all those into physical objects, into media, into mediums, right? He's going to bend them. He's going to put a kilogram on there. What's a kilogram? A concept. So he's going to be bending this, you know, I call it a fishnet, this canvas that you see there. It's ubiquitous, it's everywhere. And you see him bending the fishnet with kilograms. And he says, I explained it. I explained gravity. And when you say, well, all of what you showed me are just concepts, abstract concept, there is no fishnet, it's number lines, that's math. There is no such thing as a field, that's math also, a bunch of numbers, a value at each point in space. There's no such thing as kilograms, those are numbers as well, units. You know, what did you explain? You didn't explain anything. I wanted to see an elephant, you know, bending something for real, but, you know, if you put an elephant on a net, right, on a fish net, then you say, okay, I understand that because you got elephant on top of a net. But that's not what they're doing. They're putting kilograms on top of number lines and bending them. That's the explanation. And they say, well, it's just an analogy. You're taking the analogy too literally, Bill. No. Physical interpretations have to be a little more literal than what these people are doing, because it's an analogy for what? Where's the analogy when you are bending, you know, number lines with kilograms? There is no possible analogy for that. You cannot say, I'm going to put an elephant on top of a net and that represents, you know, kilograms on top of number lines. Absolutely not. One thing doesn't follow. You know, you don't bend number lines with love. You know, should I put love there? What am I going to put, a heart? And say, oh, look, the love is bending the number lines. Yeah, this is the problem. The problem is that the analogy is totally irrational. You can't use that kind of analogy because it's an analogy for nothing. You know, absolutely not. And so this is the problem. The problem is that the scientific method that these people are using, that they're invoking, the one that they're applying in all these situations, is totally irrational. You know, what do people want to know? Well, people want to know, you know, why this pencil falls to the floor. They're very simple. Okay? And you say, well, do we need to do anything else? I mean, here it is. You know, I mean, we're all familiar for a million years now. You know, things fall to the floor. Okay, so all we need is, like, you know, they say, we need an experiment. We need an observation. Okay, you need one? Here's one. Okay, here's one observation. This is the only one you will ever need. And I'm going to let go of the pencil, and it falls downwards. We all know that. Okay, now we need to explain it. We don't need any more experiments. We don't need any more equations. We just need to explain why that thing did not fall to the ceiling. Why didn't it go to the sky? Why didn't it go to, you know, all the way to the moon? That's what we need to answer. And that scientific method cannot explain those types of questions. And those are the questions people associate with science and that they want answered. Okay, so you understand that? Okay, it turns out that the other day after my presentation, my lecture, I had a visit from the Circus CERN. Okay, Circus CERN came to town over here to where I live, right? And here, this is the Circus CERN. And they came in there, you know, with everything they've got. They've got the tightrope walkers, the acrobats, the elephants, and they came with the clowns as well. You know, they had all these clowns that came over, okay? And so what do they do? Well, these clowns, you know, they're the bosons, famous bozos, okay? And what do? Well, they do some slapstick kind of stuff, and they smash things in there, I guess. You know, that's what they claim they do. And because of that, they ended up with all these bosons, you know, the Higgs, the Z, the W's, and so on. So they have all these what they call gauge bosons. Okay, so this is what they think is science, you know, and it's a circus. It's a lot of fun. Really, it's you got to take it for what it is. I mean, what's the purpose of clowns? It's to make you laugh, right? So you got to take this as something that should entertain you, okay? And so, you know, don't take it seriously. It's really all in fun. That's what a circus is about, entertainment. And the problem I had that after the circus came to town, I had a visit by all the bozos. And we had a couple bozos. And, you know, it's not that just bozo, you know, came over. He brought his whole troupe. You know, I had several bozos visit me, okay? And again, the purpose of all these bozos is to entertain you, to say, they don't only do slapstick. What they do is they tell jokes, they say stupid things, irrational things, and I guess the ultimate purpose is to make you laugh. That's what a clown does. They clown around, they say things, stupid things to make you laugh. And so here's one of the bozos. He came over, and this is what he had to say. He said, Bill's version of science assumes already have all the available evidence. Okay, he's talking about evidence again, right? And yeah, again, this is one of the problems we have. They're following this ancient scientific method that we've had now for 400 years, and this is what they apply. So they're looking for evidence of some kind. I don't know why. And he puts experimentation investigation into his religious basket. Absolutely, we don't use experiments or investigation. Now, that doesn't mean, no one's going to stop you. I'm not going to put a gun to your head and stop you from doing an experiment at home at your own time, your own leisure. And I'm not going to stop you from experiment or investigating. That's not what science is. When you come to the conference, we want you to explain something. That's where science begins, when you can explain something. You had Michael Faraday. He would do experiments over there at the, Royal Society. And he would do an experiment, usually about electricity, magnetism, and he would wow the crowds. Well, yeah, that's clowning around. That's great. You do an experiment, and people say, oh, man, look how interesting that is. He made electricity. Oh, he caused a magnet to attract another, or whatever he did, right? And yeah, but could Faraday explain anything that he ever did? And the answer is no. He could only do the experiment and say, okay, there it is. I discovered, that this feature of electricity or of magnetism. That's like saying you bumped against the wall and you say, oh, I discovered the wall. Give me my Nobel. I'm the first person to discover the wall. Yeah, you discovered the wall. You haven't explained anything. That's the problem. Okay, so these people, they don't explain anything. They don't realize that that's what science is about, trying to explain. That's where you have to use your brain. But to say, I have evidence. Evidence for what? I don't want to be convinced. I just want to understand. Why are you bringing evidence? Do you think this is a courtroom or what? And again, they harp on belief. They say you have to believe them, just like religion. He's saying that. I'm saying that, okay? And no, I don't use the word believe. First of all, I get rid of the word evidence, okay? That's the hallmark of religion, because you're trying to convince people. That's why it's a hallmark of religion. Then the only purpose of evidence is to persuade the juror and to convince them. Okay, that's why you're introducing evidence. Why would you bring an experiment to the conference room, right? Because you're trying to convince your colleagues, the ones you're presenting to, right? That's the only purpose of an experiment and of evidence. And so I say it's the religious fanatics who present evidence. And you will recognize them. Why? Because they begin talking about belief. And that's what this fellow immediately harps upon. He says it's belief. And I never talk about belief, so I don't know where he got that. He's putting words in my mouth, this clown. And I guess if he's trying to be funny, okay. I didn't see the joke, but maybe someone else does, okay? And so he continues, and he says, according to Bill, testing the assumption is not science. Whether you believe my mechanism is your religion. Absolutely. I didn't come here to get you to believe in my mechanism. I explain it so that you understand it. Assumptions, we assume. That's what an assumption is, something to assume. We do not believe in assumptions. Okay? We don't prove assumptions. We don't test assumptions, the hypothesis, as they say. We don't do any of those. We present an assumption so that you understand it. Okay? And we say, look, let us assume blah, 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 blah. And the assumptions include the objects that you're going to present and the definitions, primarily those two. So, I have to show you what I mean by certain words that I'm going to be using throughout my presentation, the key words that make or break my theory. So I say, let us assume blah, 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 that the word object means this, the word exist means that. So, I have to make certain assumptions. You may not agree with my assumptions, but that's not the point. We're not here to debate the assumptions. At this point, we are just, or the definitions of words. What I want you to understand is what I mean by them, so that you can follow my presentation. Now, at the end of the show, you might say, Bill, I disagree with your definition. Great. Let's hear yours. And you're supposed to not only attack mine, show what's irrational about my definitions, but also present yours. We can't leave, there's 8 billion people in this conference room, and the doors are locked. You can't leave until we define the words properly, because we can't begin to do physics until we have certain words defined. And so the doors are locked. You have to come up with a definition. You can't say, oh, your definition is wrong, Bill. Bye. I'll see you next week. Nah, it doesn't work that way. And that's when we introduce, the bgaede respectful treatment of you. We want to treat you with the respect that you deserve. Okay, so we don't want you to believe in our theory. We want you to understand it. That's what we're here for. Just, understand it. It is irrational to test an assumption, and, you can see the theorist's assumption in order to follow the theory. That's it, in order to know what he's talking about. You want to understand the mechanism that he's proposing in physics, right? And in science, there is no place for belief. So this notion about belief, I don't know where he got it. We don't talk about belief here. Quite the contrary. So he says that, I'm insisting on belief. Absolutely not. He's just inventing that because that's what they do. All these clowns, right? And CERN and at NASA and so on. Okay, so he continues. He says, testing a hypothesis. You're going to test an assumption? I mean, what is he talking about? Only confirms that the hypothesis is consistent with observations. Again, between assumptions and observation. They say you can't make an assumption until you observe. And that's not totally true. We're going to handle that in a minute. But he says it does not validate whether or not the hypothesis is ultimately correct. And in particular, does not validate whether the hypothesis is rational. Then why are you going to test it? I don't know why he tests it if it's not rational or if it's not correct. Okay, so what's he going to test? I don't know. And so Bozo Joe, this fellow, right, he's testing the hype that gravity is mediated by particles. So I don't know why he's testing. What's he's trying to test? He's got to explain that. I have no idea what he's trying to test. And here's another thing that he says. He says, Bill says that his version of rational science, he assumes first, yes, then provides a mechanism for that assumption. Absolutely. Yeah, that's what we do. We make an assumption. Let us assume, right, that light is mediated or gravity is mediated by a pair of twine threads. What I call a rope, something that looks like this. It's a rope. This is an analogy. This is a real analogy. This is a valid analogy. Why? Because are we saying that the rope that Mother Nature uses, the one that, I'm going to use for gravity, is made out of atoms, it's red and blue, it's all that? No, none of that. It only looks like this, similar to this. And the best analogy is a rope, because I'm talking about a pair of twine threads. Very thin, unimaginably thin, that bind any two atoms. And so you can call it DNA-like, rope-like, any of those is fine, because what we're talking about is a pair of twine threads. That's it. That's the hypothesis. That's the assumption. So we're saying, let us assume. Did I say, please believe? No, I'm saying, let us assume. That's it. And how these people convert that into belief, I don't know. They say, you want us to believe in your... No, I don't want you to believe. I want you to assume so that you understand the mechanism I'm going to explain of light, of gravity, of magnetism, and so on. So I don't know. These people have this in their mind that I ask them to believe in the rope. No, I don't. Okay, so I just want to set the record straight. Here we're not here to twist your arm. We're here so that we present something. You say, let us assume this, and based on that, we're going to base our theory so that you understand it. Once you understand it, we're done with science. Go home, sleep on it, reach your own conclusion. That's the way it's handled. That's science, okay? Because it's objective. It's got nothing to do with, oh, we proved it. Here's the evidence. Please believe. None of that. That's what they do in mathematics, okay? And that's what we've been doing for 400 years. He says, however, his assumption is based on observation, sensations without which there are no assumptions. Well, not true. Here we have the story. I call it the tale or the story of the blind quadriplegic. You know, here he can't see, he can't touch, so he didn't observe anything, right? And someone comes to him and says, oh, dear sage, you wise sage, I would like for you to explain to me, you know, I saw last night, you know, that an asteroid hit the moon. And he didn't have to see it. He says, what if an asteroid hits the moon? How would you explain it? And the sage explains without ever seeing anything, without ever touching anything, without running an experiment. He just gives them an explanation for the phenomenon that this person did not even have to observe. He just says, hypothetically, what if, right? And then the sage answers the question. See how simple it is? And in fact, you know, you know, for just to challenge what he's saying there, this clown, right? It's very easy. I mean, we do have a case very much like that. His name was Stephen Hawking. He wasn't blind, but he was kind of quadriplegic. I mean, he couldn't move. He was there like this, right? He could barely talk. And after he became the Lucasian chair over there at Cambridge, how many experiments did he do? Did he go to the lab and start experimenting? Did he start observing things? Did he observe ever a black hole, for example, right? No, he started theorizing. He did some armchair stuff in his office. That's what he did. They call it theoretical physics. And he came up with all these conclusions, irrational, all of them. But, you know, so he didn't have to do any experiment. He didn't have to present any evidence. In fact, we have no evidence to this day of anything related to a black hole. It'd be a miracle if they could present any evidence whatsoever, right? No, there's no such thing as a zero-dimensional singularity surrounded by an event horizon, which is simply, you know, there's no surface there. It's not a thing. And these people are, you know, looking through their telescopes to see if they can see it out there. Yeah, good luck. So, yeah, no, we don't present evidence. We do not do experiments. And I think Stephen Hawking is a good proof, evidence, you know, of that. So please believe me, okay? Okay, here's another thing that he puts in my mouth, this clown and Bozo Joe. And he says, Bill's spoon experiment just proves that Bill is a lousy scientist and has no idea how to construct useful experiments that answer the question he wants answered. Well, the question I want answered is, you know, very simple. I'm going to let go of the pencil and I want to know why it falls to the floor. I mean, why does it fall down? Why doesn't it fall to the ceiling? And a lot of people want to answer. It's not only me. A lot of people want to know why the pencil falls to the floor, why the spoon falls to the floor, why the baby falls to the floor, why everything falls to the floor. You know, when you drop the baby, why doesn't he just stand in the middle of the air there or go upwards? That's what we want to know. And so you say, I'm misconstructing the spoon experiment. Well, here's a spoon, right? Want to do it with a spoon instead of a pencil? Here's a spoon, okay? It goes down, okay? I just want an explanation for that. And are we going to answer it with the mathematical method of doing experiments, of measuring, proving, making you believe? Is that how we're going to answer this question? This is a question of physics. It doesn't belong in philosophy for sure, you know. And he says, Bill's version of science, there it is. All experimentation that needs to be done has been done. No, that's not what I say. I say something different. What you see there, I say that in science we do not do experiments. You can do whatever experiment you want at home, at your own time, at your own leisure, okay? When you come to the conference, don't do experiments. Now we want you to explain what you know, the cause of what you concluded. That's what we want to understand. Now, so if you did an experiment, you did the experiment, the spoon experiment, okay, there it is, the spoon experiment. We don't want you coming to the conference and saying, let me do the spoon experiment for you. No, no, please don't. And don't do it repeatable, even worse, right? Just tell us why the spoon falls down. We want to understand the cause, the mechanism, right? And, it turns out that it's the only question we ever needed answered in physics. Why the spoon falls to the floor. Why the pencil, why the baby, or whatever. Why the parachutist falls to the floor. Why does everything fall to the floor? It's the only question we ever needed to answer. And you say, well, why do we need to answer that question? Well, why is it the end of physics once we answer that question, which is what I'm really trying to say here. Yeah, it's the last question that humans find the answer, and once we answer that question, we're done. We're done with physics. There's no more physics after that. And the reason is very simple, because the only way you can answer this question, the only way, let me say that again, the only way you can answer this question is if you identify, okay, the invisible, intangible things that are attached to the spoon. There are some invisible, intangible things, right, that are attached to the spoon that are forcing it to come down. If there's absolutely nothing here or there, right, then you're doing black magic. So since we can't see or touch them, right, whatever's in contact with the spoon, we can only visualize them. You have to make an assumption. That's what it's called in science. Okay? So we make an assumption of what could possibly be connecting the spoon, for example, to the earth, right? Then we can explain why that spoon falls to the floor. And once we figure that out, what the invisible mediators are, we're done with physics, because now we can explain everything in the universe that we cannot see. All the mediators out there that we cannot see or touch. Why doesn't the moon fly away? Well, because we don't see the mediators between the moon and the earth. Why doesn't the earth fly out of the solar system? Right? What is light? Well, there better be a mediator that unifies gravity with light, and so on down the line. So yeah, once we figure that question out, what causes gravity? What mediator that we cannot see or touch is working in the background that we cannot see or touch? Once we answer that question, we're done. We've seen what God sees, or what Adam man sees. He can see what we can't see. Okay, there he sees. What is it? Whatever is binding a physical object such as a spoon, for example, to the earth. That's it. And once you figure that out, you are seeing the invisible. Okay? And you can only do that with the mind. You can't do that through an experiment. Okay, so what does this bozo say? He says, relegating knowledge and experimental evidence in the column of religion is the epitome of irrationality, and not how I would define the scientific method. Okay, well, again, the clown's there to make you laugh, so he says stupid things, and that's fine. That's his job, right? No, knowledge is just belief, so we don't have any use for knowledge. Experiment, without an explanation, that's known as ignorance. Means you're an ignoramus because you cannot explain it. I mean, you just do an experiment and that's it. You say, I'm a scientist because I did an experiment. I don't think so. I think it takes a little more than just doing an experiment, like, good old Michael Faraday did. Just experiments without any explanation. Evidence, what is it used for? To persuade and convince. So again, all his words have to do with this. Irrationality. Well, what is irrationality? I mean, irrationality is his opinion that he doesn't like something. In science, we define irrationality because science is rational explanations. So hopefully we define those two words, what rational is and what explanations are. And yeah, so we define irrationality, moving concepts around. If you start moving, love around, well, you're not a very rational person. I mean, for the purposes of physics. In poetry, you can do whatever you want. In, ordinary speech, you can do whatever. You can get away with murder over there. But here, no, not in physics. In physics, rationality, you can't move, concepts around, and you better have, sound definitions that you can defend. Okay? If you cannot defend your definitions because someone attacks them, then you got a problem. Okay? And especially if you don't use your definitions consistently, rationally, scientifically throughout your dissertation. And then he talks about scientific method. Well, what scientific method is he talking about? This one, the one we just covered, this thingy, 17th century clowns. There you have them, Galileo, Newton, Gottfried Leibniz, you have Christian, Huygens, and Robert Boyle. These people, they came up with these notions of what science is that we have today. And, again, that's what we've inherited. And none of these things that you see there answer the questions we are looking for. If you look at this methodology, if you look at this notion of science, does this answer questions such as why a spoon falls to the floor? What causes it to fall to the floor? And the answer is no, because they're looking at evidence, they're looking at experiment. We've already got the experiment. We've got the evidence, if you want, We need a theory. We don't have a theory. We have our descriptions that it falls to the floor and at a rate of 9.8 meters per second square. Great. What have we learned about explanation, about the causes? Can we repeat the experiment? Sure. Do we have a critical analysis? Critical analysis of what? We don't have even a theory. What are you going to critically analyze? And verify and test? What are you going to test? What kind of test do you propose? Here's the only test you needed, right? Here is the test, okay? Yeah, there it is. That's the test. That's the only one you needed. Now, please explain it. Okay, that's all we needed. We need to find out why that stupid spoon falls to the floor. That's all. Okay, but he says that you don't need an object. You don't need a mediator. This is what he's saying. It's so funny. He's really a funny clown, right? So GR says no object needed in the vacuum. In other words, gravity just is. You don't need an object. Why? Because we can't see it, can't touch it, so there's nothing there. That's what he's insinuating. He's saying, look, we don't need an object. He says, nevertheless, that there must be an object is shared by cutting-edge research which posits quantum fields. He thinks a field is a physical object. So you can see why we need to define the word object, because these people think that the word field, the word energy, the word mass are objects. They think those are things. They've brainwashed them so much in high school and college or through the literature, and these people actually believe that and treat these things as objects. That's where the problem is. And no, field is not an object, okay? And so he just believes on the basis of, I guess, Einstein, authority, tradition, maybe, the fact that all the mathematicians raised their hand, democracy. Field is not an object, okay? So this is where the clown really requires that you laugh. It's a laughing matter. And there you have the definition of field, a value at each point in space. So no, field is not an object. You cannot treat it as a physical object, as people like Sean Carroll say. They say, what is a particle? It's a vibration, local vibration of a field. It's the excitation of a field locally, right? But what was a value at each point in space? So the values are vibrating, and that's a particle. So what's a particle? A vibrating number. That's what it is. And if that's what you think a particle is, well, okay, but you're not going to learn much by using mathematical language. They have to correct the language. That's where the problem is. Okay, and then he also curves space-time. He says, even in a perfect vacuum, space-time can still be curved. Again, he's treating these number lines as a physical object. He's talking about the curving of space-time. Okay, he said it's not nothing that's curving. Oh, okay, so what is curving? He says the structure of relationships. He's curving the relationships. What relationships? Distances, times, and paths. Yeah, he's all these concepts, right? And that's what he's curving. And I want you to pay attention to that word path. It's extremely misleading. Because, you'll hear these people say that they bent the path of light. And they always put it in those terms. And so people don't really catch that. You know, they say, what do you mean you bent the path of light? You know, around the star, like Arthur Eddington allegedly proved Einstein's theory in 1919 by saying, look, we were able to measure, we were able to see, take pictures of light coming around the sun, and it shouldn't have been there because the star was behind the sun. So the light from that star went around the sun and came to our eyes, to our camera. Okay, that was the proof that they needed to certify Einstein's theory, blessed, right? And so they talk about the path of light being bent or warped. That's an irrational statement. And it's an irrational statement because why are they using the word bent? Why are they using the word warped? Well, because they're not talking about light, okay? See, the word path can mean two things. It could be a noun and it could be a verb. And they have this noun-verb thingy in there. And so they say, we bent the path of light, and you're imagining, okay, here was light coming, and it bent light, right? So they talk about bending and warping light, but hold it, light is made out of photons, photon balls. Discrete balls. I mean, that is the theory, right? Or the assumption. The assumption is that, light is made up of discrete particles, and here you can say that the photon balls were deflected. Deflected by what? Well, they were deflected by the curvature of space-time. So the path of space-time, see, when you go to the forest, right, you have a path, and that's the road where you take your car or your bike or whatever, right? And they're saying that, you go along this path, the road, the highway, what's underneath your feet, right, going into the forest or wherever, right? And the road is curved, it's warped, okay? But not your car. Your car is not warped. Your car is not bent. Your car is not, doesn't look like a banana. And they're saying light, the car, is what's curved or warped. But I thought light was made out of all these discrete particles. So you cannot, did the photon bend? Each little photon just, bent and warped? No, they're talking about the deflection by the road. The road is the noun. What light is doing is deflecting, but they never put it in those terms, see? And we've had this for 100 years where they use this language. That's why language is absolutely important, critical in physics. You need to tell us exactly what you mean, and they don't do that. They have this duality where they say, oh, the light is curved, the light is warped. And what they're talking about is the path of supposedly space-time there, right? That's the road, right? And the photons are little balls that are deflected. They're curvilinear. They're traveling in a curvilinear way around the curved road. That's what they're saying. Okay? But that's not what. But they need to prove that it's space-time that is curved, so they say light has curved. They don't say light has been deflected. Besides, what are we talking about? Are we talking about the wave or the particles? I mean, can a wave be bent? What is a wave? Well, a wave is two fields, and what are the fields? A bunch of vectors. And what are vectors? A bunch of numbers. So what they're bending, what they're warping are numbers. That's what it boils down to. So yeah, space-time is total idiocy, just four number lines, that's what it is. And they turned it into a physical object. So instead of saying four number line, 4n, they say 4D, four dimension. Right? And that's where the problem is. And yeah, they're curving the fishnet. That's what they're doing. Okay, here we have another clown. Okay, his name is Another Clown, another bozo. Okay, so we had Boson Joe, and here we have another boson. Okay, and what does this boson say? Well, he says the point of experiments is to test hypotheses. Again, another guy who's testing hypotheses. And they're tested against the data evidence to validate or falsify them. And when you look up the word hypothesis, if you look it up, I mean, if you really do a research on it, don't just look at the definition, because you're going to get just one definition. But when you look through the internet, you find all these different notions of what a hypothesis is, and all these are taken from prominent sites. An objective or purpose, a prediction or testable statement, an assumption or guess, an explanation, a theory, and another says it's data analysis. Okay, so are all these synonyms? Is an assumption the same thing as an explanation? Is a prediction the same thing as a theory? So we have a problem, because the word hypothesis has covered like 30 bases. All the bases are covered. It's like, hypothesis means everything. We don't know what it means because it's used in all these different ways. And so we have to put the word hypothesis in its right definition, and it's an assumption. That's what it is. That's what it's always been. And all these people have turned it into all these other things. There are these different notions. I'm sure you're going to find a few more if you look around, right? Those are the 6 ones that I found. And we don't test assumptions. So what this fellow's talking about running a test, experimenting on the hypothesis, who knows what he's talking about? You don't test assumption. You don't do an experiment on assumption. You can criticize assumption. You can attack an assumption saying your assumption is wrong. It's irrational. Really not wrong. Wrong is an opinion. You can show that the assumption is irrational. That's the only thing you can do. Okay? If you can show that the assumption is irrational after you define the word irrational, right? Then yes, that assumption goes away. Okay? Otherwise, your assumption stays. And, this is the way we formulate an assumption in science. We say, let us assume that God exists. We don't say, do you believe in God? Do you believe in the existence of God? And the other guy says, no, I don't believe in the existence of God. Yeah, the third guy says, I don't know if to believe in the existence of God or not. No, all those people are irrational. The way we say it in science is, let us assume that God exists. And now you're going to do something with this God thingy. Okay, you can say God created the world, or God made the flower grow, or whatever you want to theorize about. But that's the way we say it in science. God can never be a theory. God can only be an assumption, a hypothesis. Okay, so, how are you going to test the hypothesis? Anyways, I'm wondering. Okay, here's another thing that this bozo says. Oh no, this is the AI. We look up the word hypothesis in the AI, and he says the following. This is what R2D2 tells us. He says, a hypothesis is a what? Proposed explanation, right? But then it says it's a testable statement that predicts. And so again, it talks about evidence and so on. So, they have all these notions. This comes from the AI. And, that's managed by the mathematicians. They're the ones who put this stuff in the bot, right? And so what are you staring at? Well, you're staring at a contradiction. What is a hypothesis? So yeah, the word hypothesis, very dangerous, because nobody knows what it means, and that's why we had to define what a hypothesis is, and it is an assumption. What is an assumption that we need for physics? We need the objects that you're going to be using. So we say, let us assume, right, that light is this, or gravity is that, the mediator of gravity, the mediator of light, right? And then you have to define your terms. What is an object? What do you mean by exist? What is location? What is motion? You have to define all those key terms that you're going to use throughout your presentation. That's the way it works. Okay, this is Bozo again. He says the following. He says, do you have a testable, falsifiable model for this thread? See, I propose that there's ultimately a single thread in the entire universe that weaves all the atoms and the interconnecting electromagnetic ropes, pair-twined threads. And he's so this fellow doesn't seem to understand that it's an assumption. We make an assumption that there's a single thread in the entire universe, and this thread weaves around, as you can see there in a little picture, if you can see that well enough. You have all these steps. It goes from the single thread, it twines around itself, it creates all the atoms and the interconnecting ropes, as we call them, and there you have our main system, our main proposal, which is two atoms bound by an electromagnetic rope. And with this, we're going to use that assumption, Did we ask you to believe it? No, it's an assumption. We asked you to concede the assumption so that you can understand the theory. What's the theory? That an atom pumps, goes up and down, in other words, expands and contracts, and torques the rope. The torsion is what is light, and you can see there on the upper right all those little stars, or you can call them atoms if you want, connected to each other, and that's going to explain gravity because they're all bound to each other. And we have an explanation based on that model. Again, we have explanations. Do you believe in them? We don't care. Whether you believe or not is irrelevant in science. Okay, what we do is explain so that you can understand the theory. Okay, and but my assumption is the same thing as what quantum mechanics does. Have they observed the particles? Have they proven particles? Well, absolutely not. They've never seen a particle. They've never observed a particle, right? They just make an assumption. They don't realize that they're making an assumption. They say, we observed. And so people say, well, they observed the particle. I mean, who can challenge that? They saw it. And again, that's testifying, witnesses, right? We kill the witness in science. No, that's not the way it works. You make an assumption because that's what they're doing without knowing that they're doing that. And then he says, and then the question is, how do you test an invisible, intangible entity? I mean, you got the mediator of light, right? We can't see the mediator. We don't know what's in there. So how are you going to test that? Well, what kind of test do you propose to get an invisible, intangible mediator, right, for gravity or for whatever? And then or for example, magnetism, right? And there you see right at the bottom that's exactly what they do with the wave. Are we going to falsify a wave? How do you falsify a wave? A wave is just a bunch of numbers. You have the electric field, the magnetic field, two fields that make up the electromagnetic wave, the famous wave, transverse wave, right? And what are the fields made of? All those arrows. What are those arrows? Vectors. And what's a vector? Magnitude and direction. So we have numbers made of numbers made of numbers. That's what a wave is. And they put this thing in motion. So how are you going to, what kind of test do you want to run to test this hypothesis that light is mediated by a bunch of numbers? Okay, well, what test do you propose? And that's the issue. These people don't even know what they're talking about anymore, because we're going to test a hypothesis. What does that mean? Please tell us. What is your hypothesis? That light is mediated by a wave. Okay, how do you test it? How do you prove it? Okay. Says that I mock observations. Yeah, observations have no place in science. And says you mock the role of the observer. That tells me you've never engaged seriously with quantum mechanics. Observation and measurement affect outcomes. And again, this is the issue. The observation and measurement affect outcomes only in the religion of quantum mechanics. Okay? Never in science. Did the idiots, the IDEOTS of quantum ever observe a particle? And if so, please draw an atom. What does an atom look like? We have these atoms that you find on the internet, and it's just a little ball rolling around another ball. Is that what an atom is? Why doesn't the ball fly away? So they don't have an answer for any of that. They never saw an atom in their lives. Okay, otherwise they would be able to draw it. And did they observe the mediator of gravity? Did you observe the agent that mediates entanglement? I mean, what are you talking about when you observe? You can observe the two objects, objects at the endpoints, but you cannot observe the mediator. And so, I asked him to please produce what he observed. And what we're interested in is not the two particles at the end. We're not interested in the two balls. We're interested in what mediator is between them, right? That is invisible and intangible. That's the one we want him to illustrate, not the two balls. The two balls are easy. Here it is. I'm illustrating them right now. There it is, two balls. Great. I just need to know why when one twirls around, it moves the other one far away without a mediator. What is this, voodoo science? Voodoo physics? And that's exactly what I call it, because that's what it is. It's black magic. Okay, so here's we have evidence, the issue of evidence. He says, evidence is science. So evidence, which is what I use to persuade and to convince you, that's science? To make you believe? Is that what science is about, to compel you to believe? It says, if you reject evidence, you're rejecting science entirely. I like that. Okay. So what is the purpose of evidence? Isn't it to persuade the jurors, to convince them to change their mind? Okay. Isn't that what all these people do? Like, here you have people who do that. I showed this earlier. Have all these charismatic faith healers and preachers and whatever. And, they present evidence. They present evidence from the Bible. They present testimony from testimonials from people they bring to their shows and so on. So is that what we should believe in? The evidence that these people are, presenting? Is that what science is? Just presenting evidence? What evidence are these people going to present? Testimonials? Is that evidence? I observed the ET flying and landing in my backyard, making crop circles. So yeah, no evidence. We don't use that. And here I found in one site it says science is also often used to refer to the establishment, an elite group of peers that decide whether you know or not. Exactly. That's what it's all become. So science is often used to refer to the community of scientists and researchers who do scientific work. It is this group of people who, through practicing science, effectively define what science is and how science is done. Yeah, they could be flat earthers for all we know, but then we have a flat earth science, right? I like what Feynman said. He said, science is the belief in the ignorance of experts. Absolutely. That's what we have today. People believe, and we should not use evidence or belief, because that's what evidence is for. So if you discover something new, and the establishment votes against you, well, you're in deep trouble, right? Because you'll never get heard by anyone out there in the public. They simply will not allow your information to reach the public, because they have all these peer censors, they call them, right? And they just stop your work. That's what it is. Okay, he accuses me of doing philosophy, this another bozo. He says, we do not do experiments in science or in physics. And he said, what? Rejecting observation experiments, you're doing philosophy. But it turns out nobody defined the word philosophy. What is philosophy? Love of wisdom? So they use these words like philosophy, like if they knew what they're talking about. And you go to Stanford Encyclopedia of Philosophy, and the only word you won't find defined is the word philosophy. And we're talking about a Stanford Encyclopedia of Philosophy, probably the #1 book or reference for philosophy in the world. And the only word they don't define is philosophy. So we don't know what that dictionary is about. Okay? What that encyclopedia is about. Okay, so it's love of wisdom. That's what it is. And again, they rely on this mathematical method. Okay, I showed it earlier, and there it is again. This is what we've inherited from these clowns of the 17th century, that this has to do with math and with running experiments and just doing things over and over. What were these people trying to figure out? What's the purpose of running an experiment? Are we there to figure out what caused it? Well, then I don't need an experiment. I just need to sit at my desk, drink a good bottle of wine, and try to visualize, how Mother Nature could be doing her stuff, gravity and magnetism and whatever. I don't need to run any experiments. We got all the experiments that we need. We don't need any more observations or experiments today. So all these people think about, we need to run an experiment. Why? What's the purpose of it? Here's the experiment that you needed all along for gravity. There it is. Observation, I observed it. There it is. That's also there. Repeatability, let's do it 3 times. There we have repeatability. You got all the elements that these people look for. And after thousands of years, we still don't have an explanation from the mathematical establishment on gravity. Nobody has any idea how gravity works. And they're talking about black holes and holograms and the inside of the surface of the event horizon, and how the things go to the singularity and they never get there. And the singularity, probably because it's 0-dimensional, 0 volume, and who knows why things don't reach there, and go. And the ones who manage to go through there end up in another universe. They have all this Alice in Wonderland nonsense, and they call it science. No, obviously none of that has anything to do with science, and that's where we're at after 100 years of general relativity. here's a bozo again, and he says science is about predicting. Okay, let's see if this is true. Science is built on making predictions. Okay, so we have astrology, I guess. It's part of science. They do prediction, maybe hand, reading. They read palms or whatever, right? Einstein predicted gravitational lensing. Okay, and the whole point of scientific model is to predict that what should happen if the theory is true. Okay, meaning an explanation, right? So what is the explanation for gravitational lensing? Well, if you look it up, I looked it up at the AI, gravitational lensing, massive objects bend, what? The path of light. So are we bending light, or are we, or is it the path that the photons roll, over? What are we bending? Are we bending the path, or the road, or are we bending deflecting the photons along that path? Which one? Is the car the one that's being bent, or is it the road that's bent? Okay, that's the question. And so I say, is light mediated by a stream of photons? And AI confirms, yes, light is mediated by a stream of particles called photons. So just in case, we have the right answers from the AI here. And so the theory is bunk. It's garbage, because we don't know what's bending. And by bending, you're treating space-time, meaning time, as a physical object. You're saying time is being bent. Does that make any sense? I mean, we're not talking about an analogy here. We're saying time, is a physical object, and we're bending it. So I don't know what analogy you can put in for that, right? It's just an irrational nonsense. And so again, did the photon ball bend? Was it the itinerary that bent? What is it that bent? Okay. And again, by what mechanism did mass bend either the ball or the itinerary? How did mass bend space-time? I mean, mass is kilograms, right? And you put kilograms on top of number lines, I'm not sure what you're going to bend there. You have concept on top of concept. And so I just want him to predict an explanation. So all these clowns, they make you laugh because, they say stupid things, irrational things, and that's okay. I mean, that's their job. But just be aware of what they're saying, all these clowns. Okay, here's this clown also confuses science with technology. He says, explain space telescopes, medical trials. Well, that's technology. It's got nothing to do with science. Okay, it says LIGO gravitational wave observatory. And LIGO is all poppycock garbage. That's all it is. All of it can be washed away. It's just a waste of money. That's all that LIGO was. Okay, concluded that gravity is what? Mediated by waves. That's what LIGO concluded. They said it's waves on what? On space-time. But there's no object in physics called wave, first of all, and then space-time is 4 number lines. So what are we talking about? What's the physical interpretation? What is the theory? Okay, so they proved that gravity is the waving of number lines. Great. And so he doesn't realize that. He doesn't understand this clown. And I guess that's why he's so funny. It's funnier when they actually believe. When they're not, when they're not acting, they're actually dumb. They're not acting stupid. They are stupid. Okay, and he asks also, why does GPS work? Okay, let's see. So, why does your GPS work? Why do airplanes fly? Why does your phone connect to satellites? Okay, so again, Bozo Clown is funny because he doesn't understand that science has nothing to do with technology. Okay, science, rational explanations. Technology, developing gadgets by trial and error. Science has no purpose whatsoever except to make you understand the universe. That's it, to make you smarter in that sense. That's it. It's got no other purpose, science. And technology is something else. You develop a gadget that you can use. Yeah, that's separate. Nothing to do with science. And again, you have good old Edison. He developed technology. He knew nothing about science. He did not know what electricity was. He did not know at the time, talking about the 1880s thereabouts, he knew nothing about, what an atom looked like, or even today, what an atom looked like, what an electron looked like, what electricity was. He didn't know any of that. But he was able to develop technology by trial and error, period. That's it. And he says, does GPS prove that time, or I'm saying to him, does GPS prove that time is a physical object, can be bent and warped? And so you look it up, it's gravity be confirmed that the Earth's rotation drags what? Time around with it. It drags time. That's what these people are saying. The gyroscope measured the warping of time around a massive object. The gyroscopes were suspended and centered using electric fields. So what came in contact with the gyroscopes was something called fields. What are fields? A bunch of numbers, value at each point in space. So they have these fields, and with this they were able to prove that, the Earth drags time around itself. It's poppycock from beginning to end. None of this survives rationality. None of it survives in science at all. And here we have a definition of a quantum particle, just in case. Right? The idiots of mathematics claim they accelerate particles. At the CERN, and because this is from the CERN, Circus CERN, right? In the religion of quantum mechanics, a quantum particle is what? A magical particle, whatever a particle is, right? Whatever it has, magical properties. And there I looked it up, and those are official definitions. Particle, what? A small localized object that can be described by various physical or chemical properties. But then you have the quantum particle. What's a quantum particle? A subatomic particle with unique properties governed by quantum mechanics, such as what? The ability to exist in multiple states simultaneously and exhibit wave-particle duality. In other words, it's both a wave and a particle, and it can be at two places at once. That's what a quantum particle is. So it's got these magical properties. In fact, it's beyond magical, because nobody can imagine a particle at two places at once. Nobody can imagine anything even remotely like that, so we're not even talking about rationality. If you can at least illustrate it, you say, well, I don't believe that that's what's happening, but I can see what you're saying. But here you can't even see what they're saying, because they cannot put one particle at two places, the same particle at two places. How are they going to, please illustrate that. And so they believe in all this nonsense, and they don't realize that there's a total contradiction. It's all irrational. Quantum mechanics and general relativity are both irrational, not to mention string theory. Okay, so how do they determine some of this stuff? Like, they sent the gravity probe B, NASA did a few years ago, I think it was 2008, and they proved, again, that the Earth drags time around itself. And this is the official version, this is from the AI, right? Gravity probe B was a NASA mission designed to test what? Predictions. They test predictions, right? Of Einstein's theory of general relativity. The mission confirmed that the Earth's rotation, what? Drags time around with it, right? They call it frame dragging. And that the Earth's mass warps time, okay? So we're dragging time and bending time. Now, please try to tell me what that means. What do you mean you bent time? What does that mean? And no, it's not an analogy for anything. You can't. There's nothing I can put in there to serve as an analogy for the bending of time, because time is a concept. So it's irrational to say that you're going to bend time, warp the seconds, bend the minutes. What is that? What does any of that mean? Okay, so this bozo, another bozo, he continues. He's saying, you don't need to see gravity to study its effects. So he's saying he's just going to look at the things that he can see and not what he cannot see. Okay, we observe what it does. Yeah, but what is doing it? And he cannot observe that. Obviously, he's blind to it, right? And so it says we define it operationally through mass and acceleration. Well, operational functional definitions are irrational. Okay, they were created by mathematicians who cannot define the words at the beginning of their presentation, so they define it at the end after running an experiment or telling you the whole story. So you went through the whole dissertation without understanding what they mean by that word, and at the end of the presentation they say, that's what we meant by such and such word. Okay, so that's the way they define it. In retrospect, and they define it by an experiment. Said, well, if you understood the experiment, that's the definition. Okay, so they're defining through experiments. Okay, and it says, and because you have no idea what mediates gravity, you end up with idiocy like black holes, dark matter, wormholes, gravitons, and so on. So they ended up with all this nonsense, right? Over the years, and it's like nobody challenges us anymore because everybody just bought into the language. And so the question is, are we doing science anymore? I mean, Jesus Christ. And he insists, you don't need to see the objects. You don't need to visualize what mediator is in there. And so he says, look, action at a distance does occur. Well, yeah, I mean, we're not saying it doesn't, but, it's because you can't see the mediator. That's why there's action at a distance. There is no real action at a distance if you could see the objects, right? And so he says, you dismiss action at a distance as voodoo, exactly. But quantum entanglement and field theory show that interactions across space are real phenomena. Yeah, tell me about it. I mean, they are experimentally verified. Yeah, that there is an effect that the spoon falls to the floor, that's true. We acknowledge that. The question is, why does it? He's just telling me, it is so. It does happen. Gravity does happen. Yeah, no kidding. And so the question there is, experiments haven't verified any explanation, causes, mechanism, physical interpretations. What causes entanglement? What causes gravity? All you said is that the idiot like you lets go of the spoon and it falls to the floor. No kidding. Why? What physical entity causes the spoon to fall to the floor and not to the ceiling? That's what you got to answer. And again, I like to say that if we can answer gravity, we're done with physics completely. But look how simple this is, right? Here, let me show you an example so that you understand what the question is. These people don't even understand what the question is. Here you see a cowboy pulling on a donkey, okay? But you don't see the rope. You don't see the thing that he's pulling on. How is he dragging the donkey towards him? Is it by magic? There's no mediator there, nothing between the cowboy and the donkey. Now, if I make visible, what's in there, for example, here I'm going to put a rope. Okay, so now I've got a rope in there. Now we can understand it. We say, okay, I understand that. Do I need to know any math? Do I need to know any calculus to be able to understand what's going on there? The cause of why the donkey is being pulled towards the cowboy? All I needed was to put an object. But if you don't have an object, mediator, then you have a problem. You're doing black magic, action at a distance. So there is no such thing as action at a distance. Action at a distance just means that there's a mediator you cannot see or touch, right? But let's put a different mechanism. How about this mechanism? Okay, here we have it with waves. I mean, can you attract, because they talk about gravitational waves? Okay, there you have a wave. Can you attract a donkey with waves, whatever waves are? Because, again, you have to keep in mind that these waves are part of space-time. So, I don't know. I guess you have to imagine them like that, transverse waves. And how about this one? Is this mechanism any better? Throwing particles at the donkey. Is that how you attract a donkey, by throwing particles at it? I mean, what mechanism do you think is going to explain to you, of all those three, the rope, the particles, the waves, of why what caused the donkey to come towards the cowboy? And hopefully there's a physical mediator that you cannot see or touch for gravity. Otherwise, you're doing black magic, voodoo physics, voodoo science. That's what you're doing. And I've shown this in the past. I'd like to show it again because people say, well, Bill, where did you get the idea that there's a mediator? Well, again, you don't have to believe in me, okay? We're not asking you to believe here. Why don't you believe in authority? Here's authority for you. And listen carefully to authority, because here is someone from Stanford University, a magical physicist, so-called, right, physicist. And he's going to tell you in your face. Here it is. Listen to him carefully.
If you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. Then there's a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
So you have every atom on Earth is pulling on every atom of you. You're also pulling on it. What are you pulling with? What is each atom in your body pulling with? Action at a distance? You just pull, one atom pulls on another and there's nothing there in between them? You do entanglement, this one affects that one, no mediator between them? You have a gluon, a strong force, and it mediates, the attraction between two quarks. So how does it do it? It's a little particle that goes back and forth, this gluon? Or are you going to put what they always put, a little bed spring to show that the two quarks are connected? Why do they put a bed spring? They should just put nothing in there, right? I mean, if we're going to do everything by magic without a mediator, then, why even worry about any rationality? All that is just Alice in Wonderland nonsense, poppycock. Okay, so this clown, he's also a little upset that I called atheism a religion. Okay, and so this is what he has to say about that. He says, atheism is not a religion. It's the lack of belief. Okay, so we have, the belief in the lack of belief, or the disbelief in belief, or you can word that any which way you want it, because that's what atheists do. They just try to get around the word belief, and they can't, because atheism has only to do with belief, and they got all that from the mathematical establishment, from the mathematical method, mathemagics. Trying to paint atheism as a religion just redefines words to suit your bias. No, I'm not redefining anything. I'm saying atheism, has to do with belief. And if it has to do with belief, disbelief, skepticism, whatever you want to call it, knowledge, right? Any of those words, it doesn't matter which word you use. It has to do with belief, and belief has to do with religion only. We don't use belief. We have no use for belief in science, in physics. Okay? Atheism is simply not believing in God. He just repeats over and over, the disbelief in God, the non-existence of God, and et cetera, et cetera. Lack of evidence. So he wants evidence to prove. And so, I like to prove to him, in fact, I proved it to him the other day, that, in fact, God does exist. And I'm going to show that right now in a minute. But, atheism has to do with the religion of mathematical physics. Why? Because it relies on belief. That's why. And so, as long as you introduce belief, disbelief, skepticism, knowledge, any of those words, you are doing religion. And that's why atheism is just another religion, period. It's just that simple. Don't beat around the bush anymore, okay? Here's the definition of atheism again. One of the three religions, together with theism and agnosticism, and I'm only talking about the traditional ones, that follow the mathematical method of doing science. There it is. And what's the mathematical method? There we have the 17th centuryers. Okay, there it is. And they're the ones who talked about belief. And that's what we have today, belief. Okay, it's all about convincing you, persuading you. All the evidence, what's the evidence for? To convince you. That's what it is. That's what it's been for the last 100 years at least. That's what quantum mechanics and general relativity do. They try to convince you. Okay, and so when he says that there's no evidence, no proof that God exists, I say, look, here it is, and I show him a picture of God painted by Michelangelo. So you have this picture of God, and say, there it is, proven that God exists. He said, well, that's a two-dimensional God, Bill. Can you produce one that's three-dimensional that I can see at least? And so I get my wife and I say, there it is. There she is. You can see her. And you can even touch her. She's 3D. So, well, but that's not God. You're changing the words. No, that is God. That's God. She's God. In fact, if you say that she's not God, I'm in trouble here. I don't want to suffer the wrath of God here. So I'm going to leave you alone with her. It says, yeah, but you're redefining your words. You're saying you're redefining the word God. I'm not redefining anything. You asked me to prove the existence of God. There's the God you can see and touch her, 3D, right? So what's your problem? That's God. tell her that she's not God. And I fear for her wrath, So yeah, we prove the existence of God. But I can prove the existence of God. Here's my wife. She's in the kitchen. That's God. Okay. And he says, you've just committed an equivocation fallacy by redefining a concept mid-argument. Well, first of all, God is not a concept. God is a physical object, okay? He made the universe. He better be an object, not a concept. But these people don't know the difference because they never defined the words. They never defined words such as object and concept, so they have no idea. They use these words very liberally. Then they say that I'm doing word salad and that I'm doing semantics. Who's doing semantics is them. They're the ones who are doing word salad because they never define these terms, okay? So they use, you're redefining a concept. What concept? God is a physical object, okay? And there it is, my wife. She's a physical object. You can see her, touch her, that's God. And so we don't define objects. We point to them, name them, and I said, wife. There she is. And anyways, that's my God, okay? Not yours. You asked me to produce God, I produce my God. You don't like my God, you're an atheist then. You don't like my God. But again, we're not talking about what God does. You say, well, does she perform miracles? Well, my wife does sometimes produce miracles, and she does it by word of mouth. She makes me do things that I don't want to do, and I cut the lawn or wash dishes or whatever. Yeah, she gets me to do a lot of things by remote control. But we're not talking about what she does or what she did yesterday or what she will do in the future. We're talking about her existence. There she is. She's existing. What do you want me to tell you? You wanted a 3D God? You can see her, touch her. That's 3D God. We're talking about existence, not about what God does. First, we got to solve the question of existence. And my wife is God, no doubt in my mind. Okay, so he's saying that I'm redefining all the words in the dictionary, right? And no, we define two words. One is the word object, the other one the word exist. And he says, you're loudly insisting that only physics has the right to use the terms exist and object. Yeah, physics has a complete monopoly. Those two words are the exclusive province of physics. Then you go into to redefine both based entirely on your personal conceptual framework, not on established physical theory or evidence. Well, first of all, it's not an issue of mine or yours. It's an issue of, is it rational or not? If it's rational, then we have to use it. And right now, no physical theory has ever defined the word object or the word exist. And I don't know why he puts evidence. What evidence do you need for the word object? You need to define the word, not evidence. I mean, he's talking nonsense. And again, that's what clowns do, these bozos. You're creating your own vocabulary, redefining core terms. Yeah, but core terms, nobody defined these terms in the last 10,000 years. That's the issue. Okay, nobody has defined these words. And if you, instead of just accusing for nothing, without any justification, put down the definitions. Show me that your definition is rational. I don't care where you get it. Put a definition that you think belongs to physics, and let's analyze it. Let's attack it. Okay, let's find out what you're offering. And so I'm saying that the person doing wordplay is the one who alleges that a scientific definition is a personal opinion, right? It's not a question of opinion. It's a question of what does the definition say? That's what it is. Doesn't realize that physics requires objects. So you need to define the word object because you can't do physics without an object. Okay? And then goes through the motion of using reified concepts such as energy, field, time as objects. Okay? Never discovered that physics is the science of existence. That's what physics is. Only a physicist has complete monopoly of the word exist. The job of a physicist is to tell us what he thinks exists out there, and with that thing that he's proposing, he's supposed to give explanations of how this universe works. That's why physics is the science of existence, and only physics. There is no such thing called ontology. There's no such thing called metaphysics. There's no such thing called philosophy that deals with, with existence. The word object and exist belong exclusively to physics. Anyone crossing the line into physics or trying to use those words has crossed the line into physics, period. And that therefore a physicist must begin by defining two words that make or break his theory, the words object and exist. Doesn't realize that no one in the religion of mathematics has ever defined the word object and exist. Doesn't explain what is irrational about the definition proposed by, the proponent, the physicist, right? And doesn't propose alternative definitions. So instead of just, crying and whining, right? What he should do is say, look, this is what is irrational about your definition. Not saying, instead of saying, oh, but this is your definition, Bill. No, forget about my definition or Johnny's definition. Is the definition rational or not? Why is it irrational? Please define rational and irrational first. That's the first issue. And then give us a counter proposal. What do you propose for the words exist or object? Because they're nowhere to be defined on planet Earth. And so this notion that he has in the back of his mind, this clown, he says, oh, they've been defined for physics. We've been using them for 1,000,000 years. No, there's never been a definition of the word object and exist. And I can prove it to you. You want proof? Here's proof, okay? Just take it from me. Here's evidence, proof, certification, verification, falsification, the whole works, okay? I'll give it to you in one shot. Look for any textbook of physics on planet Earth. Pros and cons, people talking in favor, people talking again. Go into the electric universe and whatever they wrote. Go to any book on planet Earth. See if they begin by defining the word object and the word exist. I've never seen it in any book. I haven't looked at all of them, but I could swear that there's not a single book on planet Earth, in China, in Russia, in Africa, in South America, in Europe. Nowhere will you find a book, textbook of physics, right, that begins by defining the word object and the word exist. And that's why nobody knows what an object is or what exists out there, and because they don't know that, they cannot explain gravity, light, magnetism, electricity, etc. That's why. So yeah, I have a right to ask, to demand that you define the word object and the word exist. Otherwise, you're not doing physics, because you can't do physics without those two words. And so here's the final note that he made. He said quantum field theory is based on constituents and interactions, because we're talking about, what an object is made of. And no, an object is not what it is made of, because, an object that is made of objects. So you have objects made of objects which are made of objects. That's all you said, so it's irrational because it's just an endless iteration. Okay, you don't go to hand wave that because it's inconvenient for your definitions. It's not a question of hand waving. We need to define, and this fella says, I'm not going to define it. I'm saying he's essentially saying that he's going to define an object as that which is made of objects. So he hasn't defined anything. Okay, he's just using a synonym or relying on a synonym. Right? Saying an object is made out of objects which are also made out of objects. That's all you said. And so let's get it right, bozo. Okay? It's not that objects can be analyzed by their parts. We are talking about a definition of the word object, right? The idiots of math, right, define the word object as that which is made of matter, right? That's what you find in the Wikipedia. Others define it as that which you can see or touch, right? So we have these two notions out there, both or all three notions are irrational. Okay, so any of those are easy to tear down. Don't bring me any of those definitions, because I will treat you with the respect that you deserve. Okay, they use the see-touch definition also, right? And do all their physical interpretations were reified concepts anyways, that they cannot see or touch. The field, energy, charge, waves, what are they talking about? And they use all these as physical objects. That's the way quantum mechanics works, and also relativity and string theory. It's not that science hand waves the idiocy of mathematics because it is inconvenient for the definitions of physics. It's that, the definitions render irrational all the theories of quantum, relativity, and strings. That's why you elude defining the words and call it semantics. He dismisses it as a semantic argument. So yeah, another boson, he's got to go back to the Circus CERN, okay? And do his clowning around over there, because here we're going to put him straight. We're going to set him straight on the correct path. Okay? Anyways, I'm going to open the floor for questions. Keep in mind that there's like a 10-second delay between the time I answer and the time you get the information, okay? Just the system is like that. So, light travels quite slowly these days. Any questions that you've got, go ahead and I'll see if I can answer them today. Otherwise, I'll give you a rain check, okay? So let's start. Give you a few, like a minute or so, to come up with questions. Okay, one person says, what questions do you have about the rope hypothesis that you feel like you still have not answered yet? What questions or models are you currently working on? Okay, so let me just say that, you're talking about something that is exponential. Do I know every instance or every observation, every experiment that's out there, and have I answered all of them? No, I don't even think I know them all, let alone answering all of them. What I've done with the rope model, that's what's in the books, I've got a couple of them out there, is answer the basics. I'm setting the new course. I'm saying, look, what's out there are not particles. What's out there are not waves. That's what we've had for the last 400 years at least. Particles we've had for a lot longer. And I'm saying neither waves nor particles answer any questions. We have a new model. The model is the rope model, okay? And with it, do I answer all questions? No. Obviously, I don't even know if there are questions I haven't answered. I try to answer as many questions that I can. And all I can tell you, I can answer the basics, okay? I can say that, if this is the main system, right? Rope connecting two atoms. My fists are the atoms, right? The atoms expand and contract. By doing so, they torque the rope. And that torsion is what we call light. And, if you look at torsion, it's the fastest thing imaginable. That's one thing. So we can now answer why light is so fast. It's fast because it's a torsion. Torsion is the fastest wave imaginable. Okay, so we're talking about one explanation there. The other thing it explains is why the speed of light is always a constant. Because if it's a rope, right, the more you torque it, the more links you have, frequency, and each link is shorter. Wavelength is shorter. The wavelength is inversely proportional to the number of links. Okay, that's what we can answer there as well. And then the other one that's harder to show with this, and that is why the speed of light is independent of the source, because the atom essentially is moving through the rope as the rope forms part of the atom. Okay, so it's like sliding beads on an abacus. The bead is not pushing on the wire, okay, so to speak. And so we can answer some of the basic questions, okay. We have ionization out there. We have the model of the atom. We have the model of the neutron. We have, it's quite extensive. If you look at the book, it goes through all these things in quite a bit of detail. And so we can at least answer that. And then the other thing that we had to do, that I had to do was resolve the issue of language. In fact, I considered my greatest contribution to science the fact that I discovered the word object, the word thing. We finally know what a thing is. We didn't know what a thing is or was, right, in the last 10,000 years. Nobody defined the word thing in a rational manner. So now we have a definition of the word thing, and the word exist as well. And because we have those two words defined for the first time in a scientific way, now we can give a physical interpretation to any phenomenon. And you can't cheat. Anyone who says, well, I'm going to transfer energy. No, you can't get away with that. Not in science, not in rational science, because you're transferring a concept. You're transferring love. You're transferring information. That doesn't work in science. Tell us what you transferred. You threw information. What did I catch? So the language had to change. Of course it had to change, because all the language is wrong. It's not wrong, it's irrational. And so people who say, Bill, you're redefining a new language. Yeah, it doesn't matter if it's Bill or Johnny. Look at the definition. What's wrong with the definition? What's irrational about it? That's what you got to tell me. Don't tell me, oh, we've done it like this forever, like this bozo here. He said, "Oh, you're redefining all the words that are important in physics." Well, first of all, they're not important because nobody uses them. Nobody's ever defined them. That's one issue. But the other issue is that, so what? Are we going to do something because of tradition, because we've always done that way? Assuming, they use it, but they don't use it. But assuming they use it, are we always going to do it wrong? We're going to do it irrationally? So yeah, we had to define these things, these words, so that we could talk sensibly for the first time in the history of science. Okay. Are you going to do more extinction videos? Yeah, I'm working on a book on extinction, so right now it's like I don't want to present that in videos, but essentially, I've done quite a bit of reasoning on extinction, and I think I have a pretty good idea how it's going to happen. In other words, I have an explanation for how the animals in the past and the plants in the past died, disappeared. And I have a theory that you won't find out there. You won't find it in the Wikipedia. You won't find it, anywhere out there in paleontology. So I think I have a pretty good idea how animals and plants disappeared. But, I keep tweaking it as much as possible, especially because it's related to economics. And, I try to zero in as much as I can. I'm a lousy astrologer. Some say I'm a lousy scientist, but I'm certainly a lousy astrologer, and people say, "Oh, Bill, your theory did not come true." Yeah, that's not the theory. The theory is one thing, the prediction is another one. Prediction is not part of science. I have my own opinion of when I think it's going to happen. So I try to zero in on, can I figure out more or less how much time we have left, on our clock, on the doomsday clock, right? And, all I can give you is my opinion on that. That's it. And my opinion is worth as much as anybody else's. The important thing is the theory, why, what's going to cause that part that I can, fight about. And again, I've got a general idea. I've presented a lot of that throughout the years, for several years now. And I'm not sure I can contribute any more details that I have not talked about, but you're welcome to ask me specific questions about it. That's it. That's all I can say. Okay, do you still contemplate how the atoms and molecules form their shapes, or how they combine to do stuff like life? Well, life is a big word, okay, so let's move that aside for a second. The shapes, atoms around. Remember how this works. We have no quarrel with what quantum mechanics has done, especially chemistry, right? The chemistry side of quantum mechanics. They've fooled around with the shapes of atoms and molecules over the century, for the last century. And we don't have a quarrel with that. If you look for the orbitron, on, just do a Google search, and you will find all these shapes of atoms and different combinations of them, etc. And we have no problem with that, because we're saying is that the atom is essentially, it looks like this, like a ball of yarn. So it's like, they're balls, and they merge, and when they merge, like if you have the hydrogen atom, it looks more or less like that, like a figure 8. So we have no problem with all that, because all we're doing is giving a different interpretation to that same thing that the chemists have been doing for the last 100 years. So we have really no problem with that, except that we don't have the little bead going around, the bowling ball. That's what we're getting rid of completely. Because that is nonsense, what Niels Bohr came up with. No, we're saying, look, the atom looks, again, this is the shape of the atom. If you were Atom Man, right, and you went to this invisible world, this tiny world, you would see something like this, okay? But that's what it would look like in front of you, an atom. And from there, we have no problem. Once we have that, and then we put them together, and they look like, if you look at the orbitron, that's what our atoms look like. Because that is a proper way of representing the atom, not the way quantum mechanics does it, with a little bead going around the nucleus. The atom that you see in the orbitron, works with orbitals, and that's essentially what we're saying. The orbital is a membrane, and that's what's different from the official quantum version in so-called physics, mathematical physics. Okay. What is happening to the threads when you spin or rotate magnets really fast, like engines? Well, you have these walls. Remember, you have these walls of threads that produce the magnetism, either for pushing each other away, meaning they reject each other. You have repulsion, and then you have going in the same direction. You have attraction. That's essentially the mechanism, very straightforward, I think. If you look at some of the videos there where I've illustrated that, I think it's straightforward. Okay, so what's the issue? The issue is that the threads are pulling, but they're going through also. So there's a tiny friction, but you have to look at all these threads going around like the paddle wheels of a riverboat. You have many paddles in a riverboat, and they're all going one right after another. And here you have to look at gazillions of walls of threads going around, and the other one's going around the opposite direction. They're going through each other, but at the same time, they're pulling on each other. So do they go through or do they pull? Well, the answer is both. Okay, they go through, but there's a tiny friction, and it's that paddle wheel motion at great speeds that causes the attraction between two magnets. That's the mechanism we're proposing. There is a friction at Mother Nature's level, not at our level here on Earth. When you rub your feet against the floor, well, you feel a big friction there. Here we're talking about a very tenuous friction between two threads. They go right through each other. For all practical purposes, they don't even touch each other. But I like to say that because people say, oh, do they touch or don't they touch? Well, they do touch. Yeah, there is a touch at that level, but it's not a touch that we can go to the lab and test it. There's nothing like that. And you can only imagine it, okay, that there's a very tiny friction. And if you have the sum, the aggregate of all those frictions, when you have walls of threads moving around, then yes, you can imagine them going through each other, but at the same time, that friction now causes that attraction. So you have to imagine in that context. That's the context that we're proposing it. But other than that, I don't know if I answered the question. Yeah, when they rotate really fast, that's what they're doing. That's what I'm suggesting. Okay, now what causes molecules to start defying gravity? What do you mean? Are you talking about air, like air floats? It's not attracted to the earth. Is that what you're saying? I mean, I don't know what the question is. Molecules don't defy gravity. Nothing in the universe defies gravity because gravity is connection between two atoms. Okay, the fact that a medium such as air is lighter than an elephant. The same atom in air is different. Has a different result than atoms of an elephant, yeah, or a feather versus an elephant or whatever, yeah. But you always have to look at two atoms only. Okay, you got to compare a hydrogen atom against another hydrogen atom. This hydrogen atom belongs to an elephant. This hydrogen atom belongs to a feather or whatever, right? Something very light. And they're going to act different, not because of the atom. The pull on the atom is the same for both atoms at a given distance from the Earth, right? But they belong to different objects that have a different resistance, in the air, in the atmosphere that we have here on Earth. But if you go to the moon, like, they showed, the astronauts showed, they dropped the feather and the hammer and they fall at the same time. That's done here on Earth as well. They went to a place where they removed all the stuff from the room and they drop, a heavy thing with a light one. There's this metal versus the feather. They both fall at the same time. And so, again, why is that the case? Because every atom from the feather is being pulled like from every atom of a rock. They're pulled in the same way. You got to look at just a single atom in that sense. You can compare one atom versus another atom at the same distance. That's how it works. So yeah, then once you have that, and you have Newton's equation is perfectly well. Mass, distance squared. That's it. Okay, but Life. Well, what do you want for life? I don't know what the question is for life. Life, I had to define life, and I do define that in a book. Okay, no biologist ever defined life. They have no idea what the word life means. They've been using it. They say, oh, I'm a biologist. Okay, what's a biologist? It's a guy who studies life. What is life? Oh, we don't know. And they say, well, it eats, it reproduces, it shits. It does all these things. No, it's not what you do. Okay, not in that sense. Life, that which moves against the, I originally said against gravity, but really it can move sideways as well, right? So it's against the least, the path of least resistance. Okay, so that's it. That's the definition of life. When something can move against the path of least resistance on its own, it's got to be a natural object, by the way. Yeah, then you have life. So toy truck, if you wind it, it moves by itself against gravity, or up the mountain or whatever. That's not life. Why? Because it's not a natural object. It's a secondary object. It was made by something made by nature. Nature made us. We made the robot, the airplane, the whatever. Okay, so it's got to be a natural object. So we put the word natural in there to indicate that it's got to be directly made by Mother Nature. Okay, because otherwise it has no sense. You can define it any way you want in that sense. You can say a pixel on the TV is has life. Yeah, you can do that, but what's the point of putting inanimate objects as living entities? Why would you define it so broadly to include flying airplanes? What's the point of that? No, you talk about life, people think, yeah, life is something that's made by nature, not made by us. So that's why you put the word natural. Other than that, yeah, it moves against the path of least resistance in any direction, sideways or towards gravity. Okay, did you talk in detail about the irrational stuff that happens on CERN or any scientific corporation? Well, I don't get into politics, okay? I've stopped doing politics over 30 years ago, went 3 years to prison, so I don't do politics anymore. I learned my lesson. So I don't look at what corporations do. Do they cheat? Do they lie? Do they pay scientific investigators to do something for them so that they can sell a product? Yeah, all that exists out there. It's out there. That's why I don't get involved. Politics is politics, and I just don't get involved in that because humans are humans, and they will cheat. They will do anything to get rich or whatever they have to do, right? So I don't have a problem with that anymore. I used to, but I don't have a problem with that anymore. Are there rich? Are there poor people? Yeah, there are rich and poor. It's always been like that since civilization, since we started civilization. And so that's not going to change until the day we die. There's going to be rich folk and poor folk. And is it right? Is it, ethical for someone to starve to death when another guy spends billions and travels the world and has fun and whatever? Yeah, that's the world we live in. That's not going to change, okay? I finally came around to believing that, to accepting that. That's who it is. And so I don't get involved in politics at all. What these corporations do, like to sell medicines, and they say, oh, look, this cures this and this cures that, it cures cancer, and yeah. You do your own doctoring, or try to be as smart as you can to try to, stay healthy. That's it. That's all you can do. Okay. Okay, folks. Anyways, I'll see you next week, and hopefully I can answer the question that this fellow asked. It's going to take the whole lecture. It's a long question to answer. So stay tuned. We'll see you.